partial eclipse starting at 0204 UTC, just over 15 minutes from now. We have live pictures on our screen from the town of Exmouth in Western Australia. That's where our telescopes and cameras are today. On the ground, we have time and dates Stefan Thorsen, and we have a team from Perth Observatory led by Matt Woods. And we're going to see if we can go now over to Exmouth and have a quick catch up with Matt. So Matt, are you there? Yes.
Oh, there he is, but he's not called Totally Boris. This is Matt
Hey
Woods.
guys.
Yay. How are things going over there, Matt?
Going well, yeah, going nice and well. There's a bit windy, but it's nice and clear, no clouds. So yeah, it's looking good.
Has the wind been causing you any issues?
Yeah, it was a little bit dusty beforehand. We're in what's called the Kalis property, so we're about 20 kilometers south of Exmouth, and so Kalis family is a big into fisheries and pearls, and they've lent the area to the state government. So it's a little bit of a dust bowl at the moment, but the wind's settled down a little bit. But my back of my laptop looks like it's orange, so from the dirt.
and you had quite a trip getting to the site as well, didn't you, Matt?
Yeah, do you like my beard? We left Friday from the observatory, so we did Dalwallinu, Morawra, Murchison, then Mullawa, and then we drove 12 hours from Mullawa up to basically Exmouth. So we've still got to go down, but we've done, probably definitely over 1,500 Ks at least. I'm pretty sure we're close to 2,000 Ks just for this trip. And we've been all those places we were doing astronomy nights. And we've still got to do Gascoyne Junction, Useless Loop, and Dongra on the way back. So we'll get back on the 25th of April, which is Anzac Day here in Australia and New Zealand.
So that's when you get to sleep.
That's yeah. So we've been we've got our swag. So tonight is the last night where we actually have to use our swags. The rest we're actually in accommodation. So we're looking forward to a good bed.
Good. A swag is a tent for those non-Australian viewers.
Excellent stuff.
And pretty comfortable, actually. Yeah.
And Matt, we're looking at some beautiful images of the sun on the screen at the moment. Also looking at some slightly different colored suns. So you and Stefan have got 3 telescopes set up there. Could you just briefly tell us what equipment you're using to send us these telescope images?
Yeah, so I've got we got the Celestron CPC 1100 that we usually use for the total lunar eclipses. So we brought this along because we've had to do the stargazing. So it's a good all-round telescope. We've got a Sirius solar glass filter. So it's cutting down basically most of the light that it's getting, so we can still get some color. Well, I was planning to use our Nikon D810A camera. That was until it fell off the tripod at Murchison, and I nearly walked off into the bushes and never to return. But I picked myself up, and one of our volunteers had brought a digital camera. So we're actually using a 5D or Canon 5D for this. So thank you very much to Jody, who's come up along with me and with the rest of the team, because she's basically saved my bacon for this trip. So yeah, that's her waving in the background.
Yeah.
Excellent. That sounds great. Matt, we're going to have to let you go and carry on with the setting up. Just briefly, it looks like we're seeing a couple of nice sunspots on the.
Yeah,
on the
it's good because we're coming up to solar maximum. So that's we're getting a little bit more sun activity. It's been actually pretty good so far. So the next couple of years will be very good for auroras, especially for you guys up there. But yeah, you're looking. It's only been last year or so where it hasn't looked like a golden disc, and those sunspots are massive tears in the surface of the sun caused by magnetic fields, and so they basically pull the surface apart. And the reason they appear dark is because they're slightly cooler and less bright than the surrounding areas. But eventually, what will happen is those magnetic field lines will eventually twist so much that they'll snap and they'll fling out solar flares into space. And you can also get coronal mass ejections, where you basically a huge amount of plasma coming off the sun, and you can get stuff like the Carrington event happening.
Well, we're hoping it doesn't happen right now. So we're only a few minutes from.
No.
No.
Yeah. So yeah, it's 5. No. Yeah, that would not be good considering we're in a very remote place and we need all the telecommunications
Exactly.
we can do. So yeah. So it's been about 6 months of work just to make sure we've got the right internet here, and we're caged away, so the visitors can wave at us and throw popcorn and watch us react as well, like a zoo. So.
Yeah. So we're going to let you go, Matt, because we're only a few minutes from
No
first
worries.
contact, and I'm sure you want to enjoy it
looks
there.
like I
That's
need
an
to-
exciting.
Yeah.
You
No
need to
worries.
adjust
All
a
right.
bit.
Good luck, guys. I do.
Okay.
Yes. I'm looking at it going. Oh no.
So make sure you check out timeanddate.live. There you can see more about the eclipse. We're a few minutes, like I said, from first contact, from when the eclipse starts, and Matt has to adjust his telescope there, Graham. So we'll see the moon nibble away on the sun. So we're ready for that. Look for it. Depending on, we can't exactly tell you where to look for it at the moment, right, Graham?
Right. So one thing just to point out, at the moment, we have these two images of the sun, and we can see those sunspot areas, those dark spots on the sun. We can see that actually they look like they're in slightly different places in these two views. That's because telescopes don't always give us the same orientation of the view that we're looking at. Some telescopes flip images top to bottom. Some images flip images from left to right. Yes, that's why we can see these sunspots looking like they're in slightly different places on the sun, although all our telescopes are, of course, looking at the same object. So likewise, when the partial eclipse starts, when we see the moon start to eat into the disk of the sun, it will look as though the moon is coming from different directions. It's all down to the telescope and how it's flipping the image before it arrives on our screen.
So we'll just have to keep our eyes peeled to see which telescope image we have and which direction it comes from. Make sure, check timeanddate.live. That's where our great colleague Aparna is making sure that all our stories are up to date, tweets, pictures, behind the scenes. So go check it out, and we will be back here soon. Watching a total solar eclipse on time and date. We're currently streaming from the Northwest Cape in Western Australia, and we're a little under an hour and 20 minutes to totality. We've got our timeline there showing us that the moon is moving down through its partial stage, inching towards totality there. So if you're wondering about the UTC time, there's also time right below here that you can compare to, so you know what time it is. And we're looking at a telescope image here that's quite overexposed. That's to show those prominences that are coming out on the left. And what exactly are prominences?
Yeah, we're seeing some beautiful prominences, as you say there, Anna, on the left-hand side of the sun in the main image. When we look at those smaller suns on the right-hand side of the screen, it's easy to imagine that the sun is just calmly sitting in the sky, but the sun is just an incredibly active place. The sun is a big ball of plasma, a plasma being one of the fundamental states of matter. We know about solids and liquids and gases. If you heat up a solid, you get a liquid. If you heat up a liquid, you get a gas. If you heat up a gas, you get a plasma, a charged gas where electrons are ripped away from atoms and you have these charged particles moving around. This creates all kinds of magnetic fields, and this is what creates all this activity that we see on the sun, like the sunspots we can see in the small pictures on the right-hand side, and like these enormous structures that we're seeing in the main image, these prominences. These are huge jets of plasma that are being thrown up from the surface of the sun by the intense magnetic fields that the sun is creating. And yes, we can see some beautiful examples of these on the left-hand side of the main image.
So we're looking at prominences, but we're also looking at a solar eclipse. And I can explain a little bit what a total solar eclipse is. So you've got the sun, the moon, and the earth lining up. So the moon comes in between earth and the sun and blocks out the sun's rays. So when you're standing on earth and looking up, you can see exactly what we're seeing here, the moon eating its way into the sun's disk. And during partial eclipse, you can see it. We're not seeing it move really fast. It's kind of slow, but as we get to totality, it moves really, really quickly. And only a few things in astronomy happen that quickly. So we're going to be busy at that point, enjoying all the different stages of totality. So don't blink, you'll miss it, and stay here so you can see it.
That's right. Keep with us as we inch our way towards totality, when the sun will be completely covered by the moon, coming up a little under 1 hour and 15 minutes from now. In the meantime, don't forget to check out timeanddate.live for more information about this eclipse, about the people that we're working with, and there's pictures from around the world. And Anna and I will be back shortly.
You're watching a total solar eclipse on Time and Date, and it's from the Northwest Cape in Western Australia, and we're about 1 hour away from totality, just over 1 hour. We're looking at some gorgeous images here of the moon eating its way over the sun, and just want to remind everyone that telescopes, they flip the images. So we've got the moon eating away from one side here on our main image from MIT NASA Eclipse expedition, but from the other two images, the sun's coming from, no, the moon is coming from the 12 o'clock position. So we're all looking at the same sun, same moon, but it's just the telescope flipping the images around. And like I said, we've got these awesome images coming in from the MIT and NASA expedition. And we had a chat earlier with Dr. Michael Pearson, because he's on site in Exmouth, and he's studying the solar corona. And he explained a few things about the corona, didn't he, Graham?
Yeah. So Dr. Michael Pearson is one of the scientists who is looking into something known as the coronal heating problem. Later on in this eclipse, when we get to totality, we will see the solar corona appear. This is the outer atmosphere of the sun, which is always there surrounding the sun. It's just that we can never see it until the sun is eclipsed by the moon, and then it comes into view. And there has always been a great mystery surrounding the solar corona, because the sun, all of the energy production takes place in nuclear fusion reactions in the center of the sun. And then as you move outwards towards the sun's outer disk, towards the surface of the sun, the temperature goes down, as you would expect. But then as we continue to move away from the center of the sun, away from the sun's surface into the solar corona, the temperature goes back up again, which is counterintuitive and doesn't really seem to make any sense. Now we think that this is all to do with the sun's magnetic field, but we don't really understand the detail of how this heating happens. So Dr. Pearson's team is looking into finding the mechanism by which the solar corona is heated, and which makes it a lot hotter than the actual surface of the sun.
And we've already talked about these sunspots and how the surface, like the sun, is more active. Would that affect it?
Yes. So all of these features we see around the sun, from things like sunspots and prominences, they're all really driven by the sun's plasma, these charged particles that make up the sun, and these magnetic fields. And yes, we've zoomed in here on some of these features on the surface of the sun, and we can see those two sunspots on the left there. These are the same sunspots that we can see in the smaller images on the right of the screen there. So yes, sunspots also caused by the sun's magnetic fields. These are areas that slightly cooler than the surrounding areas. So when we look at them on the screen here, they appear a little bit darker because the temperature is slightly cooler.
I like Matt's explanation about the surface kind of tearing apart and it cooling down in there. So they look like just dust or dirt on the lens. And are they? How big are they? They look, I don't know, it's difficult to assess.
That's the thing. It's easy to lose perspective because when we see them here, these sunspots really do look like just tiny dots. But what we have to remember is that the sun is absolutely enormous. So these sunspots that we're looking at, they are also much bigger than we realize. In fact, what we can do, Anna, is we can bring up a little size comparison to really show just how big these sunspots are. What we're going to do is we're going to briefly bring up a graphic showing the sun, and just as a comparison, next to the sun, we have got an image of the Earth to scale, showing the size of the sun and the size of the Earth to scale. And we can compare the size of these sunspots to the size of the Earth next to the sun. And that should give us an idea of just how big these sunspots are. So let's bring up the size comparison. And there it is. There is the size of the sun's disk, and that is the size of the Earth to the same scale. So now if we go back to these sunspots, we can see that they are as big or bigger than the Earth. In other words, they are enormous.
And also we can see here on this zoomed in image of the sun that it's lighter in the middle and darker towards the edges. What does that mean?
Right, this is an interesting effect here. This is the limb darkening effect, where essentially when we look to the center of the sun, we're looking down deeper into the middle of the sun, whereas when we're looking to the edge of the sun, we're not looking so deeply into the sun. This means that the center of the sun appears brighter, and around the edge of the sun there, it's appearing darker, a phenomenon known as limb darkening.
There's a whole science to this. So remember to check out timeofdeath.live. We're going to be back soon. On timeofdeath.live, you can find our news feed with live updates. We've got background info about the eclipse. We've got behind the scene images of people setting up their eclipse. It's also a bit of a special eclipse. It's actually a hybrid eclipse. So we're going to be talking a little bit about why this eclipse is called a hybrid eclipse, and we'll talk more about that when we are back. See you soon. And welcome back. You're watching a total solar eclipse here on timeanddate.com, and we're watching some gorgeous images there from our mobile observatory, Time and Date and Perth Observatory in Exmouth, Western Australia. We've got a couple of other smaller feeds there on the side. We've got MIT feed there on the top, and another one from our mobile observatory. There's a lot of Exmouths going on today on our screen. We're closing in on totality. You can follow the progress on our timeline there. So we're about, looking at UTC time, about 50 minutes away from totality there. And we have to mention that we're very grateful for all the news groups, media outlets, and other groups that are redistributing our content today. We've had a lot of emails and Zoom calls and conversations before the event of everyone that want to see this eclipse, because pretty much only seen from this little peninsula in Australia. So we're lucky to have images from there. We also want to include a thank you to our friends at Astronomers Without Borders. It is Global Astronomy Month in April, and we're part of it with this live stream here. So, we're really getting into the deep part of the partial stage at the moment, and it's looking gorgeous. So, we've got the moon's shadow here. Where is it? And how big is it? Because it's looking fairly spectacular at the moment, Graham.
Yeah, as you say, we're really getting into it now. Those sunspots that we were looking at earlier, Anna, have gone. They've been eaten away by the moon. We will see them again later, of course, during the second partial phase after totality, when the moon uncovers the sun again. So yes, the moon is moving across the face of the sun. The shadow of the moon is being cast down onto the earth, and today the moon's shadow is covering Australia, it's covering Southeast Asia, and a lot of places are getting a partial solar eclipse today.
That looks like this.
Which looks like this. Exactly right. Now, of course, what we're really interested in today is totality. The moment when the sun is completely covered by the moon. Now, if you see totality, you are in a very special part of the moon's shadow, because the darkest part of the moon's shadow in the very center is called the umbra. If you're standing in the umbral shadow, that is where you see the sun completely blocked out by the moon. Now, this darkest part of the moon's shadow, the umbra, this has touched down on the Earth. There is a total eclipse going on right now in the Indian Ocean. And the umbral shadow is moving across the globe at thousands of kilometers an hour or miles per hour, heading towards the Northwest Cape in Australia. It will be arriving there in about, 35 minutes from now. So the question, as you say, Anna, is where is the shadow now? Where exactly is the moon's umbral shadow right now? Well, we can go and take a look. We do have a live shadow map, which will show us exactly which part of the globe is experiencing a total solar eclipse at the moment. We're going to show you this map. It will show the Indian Ocean. It will show the coast of Australia. There will be shading across the map to show the areas of the globe that are getting a partial eclipse. In the middle of the map, we will see a very narrow strip, the path of totality, the very narrow corridor where the moon will appear to cover the sun completely. And somewhere over the Indian Ocean, we will highlight where totality is happening now. It will be just a very, very tiny dot on the map, because today's the moon's umbral shadow is very small. It's around about 40 kilometers, just about 25 miles across. So it's a very small shadow, as we say, over the Indian Ocean. Well, okay, let's bring up the live map and let's have a look. So there we have the Indian Ocean, and there, about halfway up the screen there, that small red dot, that tiny red dot, that is where totality is happening at the moment. That is the moon's umbra, and it is rushing towards the coast of Australia at thousands of miles per hour.
And there's something really special about this eclipse while I was rushing towards, and I was mentioning it earlier. It's a hybrid eclipse. What is that?
That's right. So the interesting thing about today's eclipse is that when we have these eclipses of the sun, sometimes the moon is slightly closer to Earth and is slightly bigger in the sky. Then it can really cover the sun completely, and that gives us a total solar eclipse. At other times, the moon is slightly further away from Earth, and it appears slightly smaller in the sky. For these eclipses, the moon isn't big enough to cover the sun completely, and it gives us an annular eclipse, also called a ring of fire eclipse, because the moon gets silhouetted against the sun and you see just a narrow ring going around the moon. Now, for today's eclipse, the moon is just at almost the halfway point. Today, the moon and the sun are almost exactly the same size in the sky. That's why the moon's umbral shadow is so small today. That's why we only have about 1 minute of totality today. It's a very short totality. And at the we saw that path of totality going across the map from the Indian Ocean, across Australia, across Indonesia, into the North Pacific Ocean. The curious thing about today's eclipse is at the beginning and the end of that path of totality, the curvature of the Earth means that somebody standing at the start or the finish of that path is actually a little bit further away from the sun because of the curvature of the Earth. This means the distance to the sun is slightly greater. The sun appears a little bit smaller. So very briefly, at the beginning and at the end of the path of totality for today's eclipse, it's not in fact a total eclipse, but very briefly, it is an annular eclipse where the sun actually formed a very narrow ring around the moon. These eclipses, as you say, Anna, called known as a hybrid eclipse, where in one location on the globe you can see an annular eclipse, and in other locations, such as where our telescopes are in Exmouth in Western Australia, it appears as a total solar eclipse.
And you say standing because that's when you're looking up at the eclipse, but nobody will be standing in the Indian or the Pacific Ocean, will they? There will be maybe some lucky marine animals that will see the annular eclipse.
Well, that's right. Yeah, the start and the finish of the path of totality today is far from land, out over the ocean. So no observers actually get to see an annular eclipse
No,
today.
unfortunately. So there you have it. It's a hybrid eclipse, and that's the explanation. So for more details on hybrid eclipses, go to timeanddate.live. We've got explanations about that. We've got other pictures behind the scenes, all kinds of fun stuff that you can find on Time and Date. So have a look there, and we will be back soon to talk about what to look for at totality. It's all happening. It's all happening. I'm excited. So we'll see you back here soon. welcome back. You're watching a total solar eclipse on timeanddate.com, and we're looking at a really cool image here from our mobile observatory in Exmouth, Western Australia. It's the Time and Date and Perth Observatory collaboration going on there, and it's a hydrogen alpha telescope, and that means that it's good for picking up these temperature, these differences that we were talking about earlier, including a prominence there on the left side. So it gets fun to look at, doesn't it, Graham?
Yeah, it is. As you say, this is a hydrogen alpha telescope, which is looking at the sun at a particular wavelength. It's in the sort of the red crimson part of the spectrum, which is why it's looking as this very this sort of very reddish color, and this is a wavelength at which the hydrogen atom is very strong. And since the sun is mostly made of hydrogen, this gives us a very as you say, it's a very interesting look at some of the activity that is going on around the sun. As you say, that lovely prominence there on the left edge of the crescent sun.
So we've got other views as well, and they have different filters, different kinds of telescopes, and that's why they look so different from this hydrogen alpha telescope view. We're about 19 minutes, I think, or less away from totality, and we want to talk a little bit about what we can see in the sky during totality, because during totality, we're going to leave the screen. We're going to leave everybody to enjoy the view on their own without us blabbing here in the corner. So what can we expect from totality?
Yes. So as we move towards totality over the next 15 minutes, that crescent sun will get thinner and thinner. It really is looking like the crescent moon there at the moment. That is still, of course, the sun. This crescent gets thinner and thinner. On the ground in Exmouth, things will start to become darker as more and more of the sun is eaten away, until in the final moments before totality, around the edge of the sun, we start to get our very first view of the solar corona. This is the sun's outer atmosphere. It extends out into space around the sun, and we may start to see its sort of ghostly appearance just before totality begins. The crescent sun gets thinner and thinner. The two horns of the sun get closer and closer until we come to an effect known as the diamond ring. This is where the opposite ends of the opposite horns of the sun meet in a final
like a flare burst.
Yeah, right, a final jewel of sunlight. And coupled with the solar corona, which is now starting to appear around the edge of the moon, it really gives the impression of a jewel set in a ring. So it's commonly known as the diamond ring effect. This final bright flare of sunlight, it then starts to break up into small blobs of light known as Bailey's beads, named after the 19th century astronomer Francis Bailey, who was one of the first astronomers to describe this phenomenon. This is where we're looking at the final rays of direct sunlight coming to us through valleys on the edge of the moon's surface. Bailey's beads disappear one by one. And when the last Bailey's beads has disappeared, that is then the beginning of totality. At this time, we might also catch a glimpse of the chromosphere. This is a reddish band around the visible surface of the sun. Again, a lot of these things, they're there all the time, but we only get to see them when the moon is blocking out that bright visible part of the sun's surface. So we may just see this reddish chromosphere, and then we are into about 1 minute of totality when we're hoping to enjoy a view of the solar corona.
And during that totality minute, Matt and Stefan are going to be super busy. They're going to be taking off filters, off their telescopes, and making sure that they're going to catch that really faint solar corona.
That's right. And this is the big challenge with solar eclipses, is that they start with the sun's full disk, the dazzlingly bright sun. And at totality, we're going right through to the solar corona, which is just much, much, much fainter. It's about the same brightness as a full moon, which interestingly does mean that it doesn't get completely dark on the ground during a total solar eclipse. It gets about as dark as it does on a full moon night. But it is a completely different level of brightness to that of the sun itself. So yes, the challenge is taking off filters, making adjustments, and switching telescopes from the view of the bright sun to the solar corona.
And if you're on the ground there and you're enjoying the solar eclipse, you might notice that the birds are going to go a bit crazy in the sky. They're going to think that it's nighttime. The temperature might be a bit cooler. It all feels very surreal. I remember from my one experience of seeing a solar eclipse, total solar eclipse. I'm going to see many more. So for those on the ground, this is a special moment, but they have to keep those eclipse glasses on.
Right. We talked earlier about the importance of not looking directly at the sun without proper eye protection. Proper eye protection means certified eclipse glasses from a reliable source. This still applies right through the partial stage of the eclipse. It applies right through the diamond ring effect and Bailey's beads. This is still part of the partial stage of the eclipse. It is only when the final one of Bailey's beads has disappeared, that's when totality starts. That's
when you can take them off.
That's when it's safe to take off the eclipse glasses and enjoy the view of the solar corona, but only very briefly, because totality lasting for, at our location just south of Exmouth, it's 1 minute, 3 seconds. In Exmouth itself, it's a little under 1 minute. It's about 58 seconds. Eclipse glasses have to go back on before the end of totality, before we get the same effects happening after totality. We see Bailey's beads, we see the diamond ring, we see the crescent sun re-emerging. Eclipse glasses have to go back on before those effects start. So it is only a handful of seconds that we can remove eclipse glasses and enjoy the view of the solar corona.
So stay put if you're not on the ground out and having this fabulous experience, and stay put here. We're going to leave you, and so you can enjoy the whole build up to totality and totality itself. And we're going to try to show it from several different angles. So we're excited about that, and stay put because we'll be back after totality is finished, and we've got a lot more of show to go through. Wow, that was a total solar eclipse, and it went about. We're still doing it. It's still a total solar eclipse. Totality went fast. Yeah,
that is always the thing with total solar eclipses. Even when totality lasts for 4 or 5 minutes, it always goes by in a flash. It never feels long enough. And today's totality was just a mere minute. And yes, as you say, boy, that went fast.
And you could see Matt and Stefan struggling with their filters there and getting them on, getting off camera, kind of the telescope view kind of drifting out. Like, it's just, yeah, it was, I can imagine them being quite relieved that they can relax again.
That's right. As you said earlier, Anna, astronomy is normally a very slow business, and things always happen very slowly. The one exception is solar eclipses and totality, when it is an action-packed couple of minutes. So yes, lots to do there with filters, with readjusting telescopes and cameras, and yes, the most active couple of minutes that astronomers can ever deal with.
Yeah, and we did see some features in there, didn't we, Graham?
We did, and we are going to be, later on, we are going to be sharing a replay of totality. So yes, we saw Diamond Ring, Bailey's Beads. We saw some really nice features around totality. We saw
Corona.
We saw the corona. We saw beautiful prominence extending. Well, we can see the prominence there very clearly on our main screen. There, we also saw that prominence during totality extending up into the corona. So yes, we have a replay that we will be sharing, and lots to talk about there.
We do, and we are also going to be talking to Stefan, and he can explain. He's probably still out of breath, so we'll see how that goes. And we are also going to talk to NASA expert Dr. Kelly Couric. She's a solar scientist, so we've got a lot of interesting stuff still coming up in the show, and the eclipse isn't over. We're still looking at it. So we'll see you back here very soon. You're watching a total solar eclipse here on Time and Date, and we've just had totality. I say just, it's 20 minutes ago, but we're working crazily in the background here. We've got a hold of Stefan Tossen, our chief eclipse chaser here at Time and Date, and he's on the ground in Exmouth, Western Australia. So let's see if we can get him up, if his mobile phone isn't too choppy.
Hello.
There he is. Hi, Stefan. How was it? What was totality like for you?
I got on kind of saying to everyone that they should look at the event and not look at the cameras and that kind of thing, and I didn't get so much time to actually watch it myself because I was watching everything else, but I got like two times 5 seconds, which I kind of looked for the things I knew I was looking for, so it was a great experience. And of course it got dark, and there's also lots of things happening the 5-10 minutes before, and especially the last few minutes are kind of exciting when it kind of gets really dark or very close to dark. So yeah, so it's an amazing event. Everyone was kind of happy because we had kind of some bit of windy early morning, and there was quite a bit of cloud this morning as well. So it's a bit like we hope to just get away, and it's super clear and nice at the moment.
And did the temperature cool down? Did you feel like it got a bit cooler?
Yeah, I had on my list to bring a temperature to measure temperature, but I forgot that part. So but it definitely got cooler. But not still in a t-shirt. That's fine. But it definitely got cooler. Yeah. But especially not necessarily the eclipse itself, but the 10 minutes, 20 minutes before, and still it's kind of a bit cooler.
Huh. And how was the hectic experience with the telescopes?
There's always this filters off. You take filters off about 20 seconds before, but then one of the telescopes got a bit moved, so it kind of lost a bit of the sight. So then it's quickly get it back again. So that adds a bit to the kind of hectic environment, because it's but it's kind of that minute just like felt like 10 seconds. It just went so quickly.
Yeah, and Stefan, we know that you're all still busy there because we still have this partial eclipse to go. We've been having a couple of questions in from viewers to this show asking about the different suns that we're looking at. The main image that we're looking on our screen at the moment, this is a very overexposed sun. This is a deliberate thing to bring out the prominences.
Yes, so you can either kind of get the surface fine or the prominences. It's a bit hard to get them both. Sometimes prominences are super strong, so you can get them both. But in order to get a bit more prominences, you overexpose the surface, and then you get it like this. So it's kind of a interesting look, and this is also what you saw during totality with your naked eye. Some of it is just as the most visible part of it. With the bright eye, you saw much more, obviously, during the totality.
Right, indeed, yes. And in fact, you're saying that it was interesting to look at the difference. Actually, in that small telescope feed in the top right corner, which is where the exposure is a lot less. We can't see the prominences, but we are now just seeing that sunspot
it's coming back,
reappear. We lost it during the first partial phase, but there it is. It's just being uncovered. So yes, we can either enjoy the sunspots in the one feed, prominences in the other feed.
Yes, we can. And thank you, Stefan, for doing such a great job. And thank you to Matt too. I'm sure he's busy behind the scenes. And if people stay tuned, we will hopefully have a replay of totality. We're working hard behind the scenes to get this done, and we're looking at an interview with Kelly Couric. She's a solar specialist at NASA, so be sure to have a look at TimeDate.live as well. We've got loads of stuff going on there, so we will be back very soon.
Way too much give
Welcome back to Time and Date. We have been watching a total solar eclipse live from Western Australia. We are into the second partial phase. The moon is slowly moving off the face of the sun, and this eclipse has about another 50 minutes or so to run. Now, for the past few eclipses, Time and Date has been delighted to be collaborating with NASA on their Eclipse live shows, and they've been using our images and telescope feeds as part of their programming. For this eclipse, they had a live show featuring the sun expert, Dr. Kelly Korek. And we are delighted to say that just having finished her show with NASA, Kelly is now going to be joining us here on Time and Date.
Hi, Graham.
There we go. Excellent. Great. And hey, thank you very much for joining us, Kelly. So Kelly is a heliophysicist, and she is NASA's program manager for eclipses. Mm-hmm. So I think, Kelly, the first question we need to ask is what is a heliophysicist?
Yeah, thanks, Graham. Yes, a heliophysicist is a physicist that studies helio, or the sun. So we study all of the effects of the sun on the Earth, as well as all of the things that that our sun does. So things like the solar flares and prominences and these eclipses, as well as things on Earth, and the magnetosphere and the ionosphere and our atmosphere. Those are all things that heliophysicists study.
Yeah, and this is kind of a big year for heliophysics.
It is a very big year. So we are all about to have a very big year from 2023. We're going to start just around October, around the annular eclipse, and run through the total solar eclipse that happens April 8th, 2024, and then through December 2024, when Parker Solar Probe makes its closest approach to the sun. It gets 96% of the way to the sun from the Earth. So this big year is actually a concept that comes from citizen science birding. And their big year means that I want to see as many species as birds in that 1 year to have a big year. And so for us, we're challenging folks to have as many different sun experiences as you can in that 1 year. So the annular eclipse, a total eclipse, could you see aurora? What about learning about solar flares? What about learning about the effect of sun on your emotion, or how you use it in growing crops and food? So we really want everyone to have a big year with the sun from 23 to 24.
That's cool.
And you've just finished, you're all warmed up here, I can tell, because you've just finished your live show with NASA. How did it go?
Oh, the live show was incredible. There was great banter and amazing questions from the audience and audience participation. And of course, the star of the show, our sun, and the total eclipse and the Time and Date feed was just amazing to sit there and watch the prominence develop, and then all of a sudden to see totality, and it was amazing.
That's nice to hear. We've worked hard for those images. And what was your favorite question? What was one of the exciting questions that you got?
So I think one of my favorite questions was something that I just hadn't thought about, is how common are lunar eclipses more common than solar eclipses? And, I hadn't thought about it, but it was great to also be able to then have a phone a friend. We had some other colleagues in the background making sure that we could have some fact checks there, because my sense was that, it does seem like there was more, lunar eclipses, or you hear about more people being able to see them. And they were able to get some information about the fact that, yes, actually there's more likelihood to see it because a larger swath of the Earth can see a lunar eclipse, but they actually happen happen just about the same amount as a solar eclipse and normally happen in pairs, about either 2 weeks before or 2 weeks after a solar eclipse. So it was just a very interesting question to also test my, sensibilities of like, oh, how do I figure this out? And sometimes, even a scientist needs to phone a friend and be like, hey, you know the answer?
Oh, this is true.
Excellent stuff. Yeah, well, we've been enjoying some great images today. We've had sunspots, prominences, the corona. So much to see. Was there a particular highlight for you today, Kelly?
Definitely. I think there was that little prominence in the lower left-hand corner of the feed that stuck out early as the moon made contact and was there the entire time. And then once you got to totality, you kind of saw all the things that were around it, that it was sticking out there, but there were so many other things around it that were also dancing and moving, and all this plasma and gas is constantly moving on the sun. And to see that was my favorite part. It was the part I was rooting for.
Yeah, we were enjoying that bit too. At one point, it looked like it was just flying in thin air, that prominence on the feed.
Definitely.
And yeah, you were mentioning 2023, 2024, big year for the sun. We've got 2 massive eclipses coming up. There's an annular solar eclipse going across the US in October, and then another one in less than a year from now in April, a total solar eclipse there going across the US. So what are NASA's plans for these eclipses?
NASA has a lot of plans for both eclipses, and priority is is our number one priority. So safety is our number one priority. And our what our main message is about having the safe viewing ability. So you need glasses for the entire time for the solar eclipse, or an indirect viewing method, meaning your back is to the sun and you're looking at either a colander or a pinhole or a serial box. There's a lot of different ways to make some pinholes in order to view it indirectly. And so for the annular safety at all times. And then during the total, we want you to keep your glasses on except for totality. And then we want you to experience that corona, that amazing time, especially as we get to solar maximum. There was so much activity and so many different things that popped up as we got to totality, and it should be even more active in the next year. So it'll be really interesting to see that. Other priorities that NASA has is really broadening participation, is that letting everyone know that they belong here, belong to learning about the sun, belonging in science, belonging to these amazing experiences. And you don't have to be a full-fledged PhD scientist to appreciate this and to really belong in it. So we really want to broaden that participation. We will be doing a lot of science here too. There was a kite experiment that was flown in Australia that we're anxiously looking for the data from, and we're hoping to do other science experiments in 23 and 24, like launching a rocket to test the ionosphere, a layer of the atmosphere of the Earth, and how it reacts to eclipses. So we're going to send off a couple of those 3 rockets into each eclipse to study that.
Wow.
So lots of science, lots of fun and interesting things. We're also engaging the public in terms of places to view and educational outreach activities. There are things like ballooning events, citizen science projects folks can get involved in, like Eclipse soundscapes. There's a lot of different things that NASA's planning for these 2 eclipses.
Oh, it all sounds really exciting. I want to be a part of one of these experiences. Well, we're going to be in the US for it, so maybe we can catch up. Thank you so much, Kelly, for joining us here on the show. It's been a pleasure having you, and you get to go to bed now.
Thank you so much. It is my pleasure. Thank you so much for having me.
Thank you. And we're already deep into planning for our annular solar eclipse in October. We are going to Roswell, New Mexico to be live streaming that. And for that one, we're going to be on the ground. So we're excited about that, aren't we, Graham? Go to timeanddate.live. There's loads more info there about this eclipse, other eclipses, behind the scenes, all the fun stuff happening on social media. So go there and check it out. But we still have a little bit of Eclipse left. So we're going to be here for a while more. And we'll see you soon. Welcome back. I'm Anna Buckle. This is Graham Jones. We're still watching a total solar eclipse, but we're inching towards the end of it. The moon's disk is moving off the surface of the sun, and we have a replay. We're very excited about this. It's the MIT NASA Eclipse Expeditions feed that we're just going to show you from start to finish, and we will talk you through it. So, okay, Gustav, you can start it now so we can see what it looks like. Oh, and there you have it. That's already there, the diamond ring effect, right?
Yeah, so this is as now we're just moments away from totality here. The filter has come off the telescope, so the bit of the crescent sun that is still visible is super bright there. We're starting to see the solar corona around the edge of the moon, and this is heading towards the diamond ring effect. We've sort of got this ring around the moon of the solar corona, and that final bit of the visible sun is shining like a jewel. We move swiftly from the diamond ring into Bailey's beads. That bright jewel starts to break up into blobs, and as the final one of those blobs disappears, this is now the start of totality. Now the full splendor of the solar corona comes into view. We can still see those wonderful prominences in the sort of the top right edge of the sun, and this is 1 minute of totality.
And it looks pretty amazing. And when we were in Argentina, the corona looked a bit more stretched out like wings, but this one was a bit rounder, wasn't it?
Right. The shape of the solar corona does change over the course of an 11-year solar cycle. The totality we saw in 2019 in Argentina was near solar minimum, and the solar corona was rather stretched out like wings. Today, it's a lot more symmetrical. It's a lot rounder. That's our minute done. We are coming back to Bailey's beads. These blobs of light appearing in that bottom right corner, and they're now merging together to again form this jewel of light, the diamond ring with the solar corona around the edge of the moon there. Now the bright crescent sun comes back. The solar corona disappears. That's the last time we'll see the solar corona from Earth until the next total solar eclipse.
April 8th, 2024.
April the 8th next year. That's correct. So that was the very brief 1 minute of totality of this April 20th, 2023 total solar eclipse.
Because next year it's going to be much longer, the totality, right?
That's right. So next year we're up to over 4 minutes of totality. That's one of the reasons for that is that the moon is closer to the Earth, bigger in the sky, and can cover the sun for longer.
There you go. And we've moved into this zoomed in image of the sun. We've got some sunspots, we've got some prominences, so we're really getting to study them here.
That's right. This is a great shot here showing a partially eclipsed sun with those sunspot features in the center, and some nice prominences around the edge of the sun's disk.
And Pac-Man eating us in the corner there.
Exactly.
And that's it from us for now. We will be back very soon. Check out timeanddate.live for more information about eclipses and about this eclipse and other interesting pictures behind the scenes, all the fun stuff you can find there. And we will see you soon. So we're still watching a total solar eclipse here on Time and Date. We've seen totality in Australia. We've watched a beautiful replay of that and seen what was happened during totality. But in southwest Papua in Indonesia, it's all about to happen.
That's right. The main image on our feed right now is coming from the city of Sorong in the province of southwest Papua in Indonesia. These images are coming to us from the BMKG. That is the Indonesian Agency for Meteorology, Climatology, and Geophysics. Yes, today, the city of Sorong is getting a 90% partial eclipse, and we are at about eclipse maximum now. Anna, we looked earlier at our live eclipse shadow map. We looked at the location of the moon's umbral shadow, the darkest part of the moon's shadow, where if you're in the umbra, you can see the moon completely cover the sun and cause a total solar eclipse. Today, the moon's umbral shadow is incredibly small, only about 40 kilometers or 25 miles across. When we last checked in on our live map, the moon's umbra was over the Indian Ocean and rushing towards the coast of Australia at thousands of kilometers per hour. Well, it is now passed over the Northwest Cape very briefly in about 1 minute. That was the wonderful 1 minute of totality that we saw in Exmouth. It then continued northwards and eastwards. It crossed over the country of Timor-Leste and now heading across Indonesia. And I think we can go and have a look and see where it is. So
let's bring out the map again.
So here it is. Yeah, so again, the shaded areas are indicating where there is a partial eclipse, and that very, very tiny red dot in the middle, that is the moon's umbral shadow. That is where a total eclipse is happening right now. So it's passed across the province of West Papua, and it is now heading out into the Pacific, where it will be then taking off and leaving the Earth's surface, not to hit the Earth again for about another year until the next total solar eclipse in April next year.
Yep. So we're kind of running towards the end of the show here, really, because everybody's getting to see the partial and total eclipses, but it's not completely over. Almost over. We will be back soon. Check timeanddate.live. Go and hit subscribe on YouTube, and we will see you back here again for one final time before we say goodbye. So see you soon. we're at the end of a total solar eclipse here, brought to you by timeanddate.com. That's us, Anna Buckle and Graham Jones. And we're just looking at that final bit of the moon leaving the sun's surface there, Graham. And we're just hoping to just, this is called fourth contact.
This is fourth contact. Yes,
Yeah.
This is the moment when the moon leaves the disk of the sun. And once again, we are back to that full disk of the sun, which we haven't seen there in Exmouth for the last 3 hours, because that's how long this eclipse lasted there on the Northwest Cape.
And we've got this image overexposed to show those prominences. They're kind of hiding a little bit back there down in the left-hand corner. And we're hoping maybe there's a prominence around exactly where the moon leaves the sun's surface fairly soon. Oh, almost, right, Graham?
Almost there. Yes, we can see that there is still just the tiniest nick in that edge of the sun. But I think now the moon has now moved off the surface, and we are back now to that bright solar disk.
Very bright at the moment, being overexposed to show us those prominences. So,
exactly, yes.
Yeah. So this eclipse is unfortunately coming to an end, and we have a lot of people we want to thank, and this is where I have to look at my list. Thank you again to Matt Woods and Stefan Thorson and the whole team from Perth Observatory at the Mobile Observatory in Exmouth, Western Australia. We're hugely grateful to the support from Penny Griffins and the team at Western Australia Government. They've been really working hard behind the scenes leading up to this eclipse, making sure that we had everything we needed on site. Luke Perot and the team at Telstra has helped us have enough stable bandwidth to send this eclipse across the globe. We've got MIT NASA Eclipse Expedition, Michael Person, Theo Boris and Milo Dantowitz. They've been streaming this eclipse from the Mantarays Ningaloo Beach Resort in Exmouth. Tata Mifta Fazaya, I was going to say it wrong, Fazaya, and the team at BMKG in Indonesia. That's the weather team there. Need to mention all the all-nighters here in Stavanger HQ Time and Date. We've got Gustav, Andy, Jason, Aparna, Ada, Kobe, Constantine, Matthew, Ina Maria, Adalbert, David, and Anya, who have been working really hard behind the scenes to make sure that everybody's got snacks and everybody's got images and everybody's happy during this all-nighter that we've been having here at Time and Date. But it's not completely over, Graham, is it?
No, so the eclipse has now finished in Exmouth, Western Australia, but there is always another eclipse on its way. And we have 2 more live streams coming up this year on Time and Date. And we have another big live stream coming up 12 months from now. So we can have a quick look ahead at the eclipses that are coming up. So let's take a look at the calendar of forthcoming live eclipses on Time and Date. So October the 14th, an annular solar eclipse across North America and South America. This is where the sun forms a ring of fire around the moon. We are going to be on the ground in Roswell, New Mexico, for a live stream of this eclipse. 2 weeks later, we have a partial lunar eclipse across Europe, Africa, and Asia. And again, we will have live telescope images of that on Time and Date. And then just under 12 months from now, the next total solar eclipse. The path of totality runs across Mexico, the United States, and Canada. And again, we will be on the ground in North America for live images of this eclipse. So that's it for today from Western Australia, but we will be back with our next eclipse live stream, seeing you from, we'll be back in 6 months from the city of Roswell, New Mexico, for the annular solar eclipse, October 14th.
Pretty excited about that one, I have to say. So we're going to leave you now to enjoy the sun and look at those beautiful prominences happening there, and be sure to subscribe to our YouTube channel. Go to timeanddate.live. We've got loads of resources there. We've got our night sky map, planet pages, eclipse animations, articles, all kinds of resources there that you can go and play with until we see you in 6 months. So bye-bye.